Very good morning to all of you, the yeah, or the distinguished panelists on the dais and other distinguished guests of the dais. I am Umamaheswaran. I am from ISRO. Till recently, I was the director of Human Space Flight Center, leading the Gaganyaan program. Now I am an advisor in ISRO, a Satish Dhawan professor, and continuing to contribute in ISRO. So, first of all, let me thank you, the organizers, for inviting me and making me a part of this very, very relevant topic that we are discussing today. And thank you for that. In the morning I was very comfortable, but now this timer is staring at me and I'm getting jitters. But Shashi assured me that slightly you can exit. But I assure you that I will be very brief. So I will start with the Sustainable Development Goal significance. As you all know, that the entire globe is now concentrating and is unanimously agreeing that we need to follow up the sustainable goals, so that policies like reaching certain milestones by 2030, even the recent last week COP meeting was addressing that. So, and as you all know, this directly leads to the basic question of our existence in the long term. So, not only in Earth, but in space and other areas. So, one of the major goals is development of education and industry sector. They jive together, the synergy of education and industry sector, and this is absolutely essential if we want really become, apart from Atmanirbhar, Vishwaguru in this area. So you cannot deny that the requirement for a synergy and a sync between the industry and education, where there are large gaps presently available, the role of technology cannot be said more. This is indeed the need for the hour, the capability to bridge the digital divide by providing teaching, learning, assessment, and continuous professional development solutions is absolutely essential. And we are very glad that the National Education Policy 2020 clearly addresses these aspects in the larger context. As you know, the kind of involvement of the people of India, 1.5 million schools, as in Karnataka itself, the number, as Honorable Chairman told, it's mind-boggling. So definitely technology is a need of the hour to bridge this gap. So I will not go into detail as far as the national education policy is concerned. All of you are quite familiar, I am sure. But one specific point which I would like to stress is the role of local requirements and the kind of usage of technology, as I said earlier, has been really thrust in a very clear and unambiguous way. So I will not go further into the details of national education policy, but my basic intent here is to link or try to flag what ISRO has been doing with respect to the need for education, and currently what we are doing with respect to the linkages that we need with the industry, as well as the other institutions to include into the, or to jive with the academia. So if you see, some of the activities include the revamping of the curriculum with respect to, for example, since I am from this space, the Department of Space is very keen to see that the space technology and space engineering become a part of the curriculum of at least in the higher education level and post-graduation level, which is lacking now. Of course, when you talk about space technology, it means all the kind of engineering and technology is part of space technology. It's all sorts of sciences, all sorts of engineering are part of this. But then when you are learning that individual engineering branch or engineer subject as such, and then try to get it into the space technology, it becomes difficult. the concept of integrating all these engineering, forming into a space technology or a space engineering, and make appropriate documents or learning tools for the students as well as the teachers to teach is extremely important, which is presently lacking, because definitely space technology is one of the leading technologies in the current scenario, which directly links to the development of the country, as everybody is aware of it. So this kind of system integration is another aspect which is currently lacking in most of our curriculum scenario. I was part of the Geetham board also, Geetham University, wherein when we are discussing this kind of gaps are looming. System integration, system engineering is a very, very, very essential part, which is absolutely necessary now. In a lighter vein, you can say that the ingredients for us making a sambar is very, very clear. You know what dal is required, the masala is required, everything is required. But putting it all together doesn't make a sambar. It requires a specific skill and certain additional methodologies to see that the sambar is becoming as tasty as we are used to. So this is the simple essence of system integration. And then this aspect as an educational tool or as a textbook needs to be introduced so that it becomes easy for the students to understand and enable them to be prepared when they are coming into the world of their industry or whatnot. So I'll quickly go through what ISRO has achieved or trying to do, starting with the vision of Dr. Vikram Sarabhai. As we all know, we must be second to none in the application of advanced technologies to the real problem of man and society. So over the years, what we have done, I'm not going to dwell much. We have made significant progress with respect to the generation and deployment of Earth observation satellites, communication satellites, scientific satellites, navigation satellites. We are very proud that we have our own constellation of navigation satellites. We have different kind of experimental satellites and of course significantly small and student satellites. More than 15 to 20 student satellites have been already flown into the orbit, made by the students with support from ISRO. So the technologies related to this have been developed, and the technology transfer is also taking place over the years. For example, in as early as 1977, the satellite instructional television experiment site was a revolutionary step taken by ISRO, where the experimental satellite communication was carried out with the aid of NASA's ATS-6 satellites. You may be knowing that more than 2,400 villages in 20 districts were covered, and they could enjoy the educational programs transmitted through TV. So this was an early beginning. Then another very major milestone was the launching of EduSat, which was exclusively for education, which provided two-way communication to classroom. This still is going on in many parts of India very effectively, especially in the northern India, especially in Punjab, I would say. Then ISRO has already developed the STEM portal to encourage students to engage in STEM activities connected to space science, technology, and application areas. So this portal includes online certified courses, interactive video sessions with space scientists, knowledge videos, etc., etc. is already available in portal. And now that we are giving enough publicity and enough outreach efforts to see that this becomes a norm. Then another very innovative program, what we call is UVICA, Yuva Vigyanik Karikram, or Young Scientist Program, wherein from each state and union territory of India, selected by the government, 3 students are selected and they are brought to ISRO, different centers of ISRO, and they are given an exposure of what is going on in ISRO, what is the kind of experiments that is going on, what is the kind of technology that is going on. And this is a very, very popular program. The demand is ever rising as the years or as the months go by, I would say. So this is very popular now. Another very interesting program was Unnati, Unispace Nanosatellite Assembly and Training by ISRO, wherein we are giving training to especially developing countries who are yet to make a satellite to come here and make nanosatellites by themselves. Hands-on experience is given. This is happening in Bengaluru itself, in the URSC site. Already some 6 sets of programs have been very successfully conducted, and this is very popular. in UN COPUS, the United Nations Committee for Peaceful Use of Water Space. This is being talked of in a very positive way. And CESTIP is an existing organization which part of is linked to ISRO in Dehradun, which is UNUSA, as I said, United Nations Office for Outer Space Activities, located in Vienna. So this is a center for space science and technology education in Asia and Pacific, which was founded in 1995. So this center offers postgraduate level courses in areas of remote sensing and geographic information systems, satellite communications, space and atmospheric sciences, etc. Now it is linked to the University of Hyderabad, wherein so the degree is being given by that. That linkage is already established. So these are the kind of efforts that ISRO is taking to link academia with the institutions. Another very, very popular, getting popular, I would say, is the School Bhuvan, which is equivalent to your Google Map, which portal provides maps based on learning to bring awareness to the students about the country's natural resources, environment, and their sustainable development. This is getting popular now. I think I request all of you to go to Bhuvan and see the facilities and the information content that is available. Then, as I said earlier, the student satellite program is extremely popular. Last year also, as part of the 75 years of India's independence celebrations, 75 satellites were launched, as you all know. So student satellite program is very popular. Lots of requests are coming, and we are enabling them also. So this kindles the scientific temperament in the Gen Next to come. Space Tutor is also a very innovative program that we have started. We are engaging with the NGOs and some educational institutions in the STEM education promotion without any commercial advantage. So basically the idea is, as I said earlier, promoting space education and creating awareness space activities and applications to the students community specifically. We are also in the process, we have already released several publications which in a very simpler way, so that especially for the students, if they read it, they will get inspired. Like these are some of the publications that we have done based on AstroSat, going to Mars, etc., etc. And many of these are in the local languages also, so that the outreach will be more. And coming to the implementation of education policy, I would like to give some suggestions in the sense, as far as the space technology introduction, as I said earlier, is concerned. There is a need wherein syllabus needs to be revamped, at least for 2 semesters dedicated to space technology. And I've shown one example, integrated design of space transportation system, which is, I think, one of its kind. It's the first textbook of this kind which is available in India. It is prepared by or made by Dr. B.N. Suresh and Dr. K. Shivan, the former chairman of ISRO. And this is a fantastic book. As a textbook, it can be taught and people can learn. So books like this kind of things can be introduced as part of the curriculum, and maybe 1-year program linkage to institutions, not only ISRO, DRDO. There are wonderful institutions in India, can be taught through projects in the UG PG level. Now the UG PG level projects are very loosely defined and connected. The real essence of learning doesn't happen. I'm openly saying that. So this needs to be changed. There should be a structured way by which whatever ISRO needs is being also in another way, the project students are also becoming a real part of what ISRO is doing or DRDO is doing. That kind of involvement is really required. So we need a regular structured program which involves the students. Maybe they can also participate in some of the launch campaigns within the constraints. So these are some of the points that I thought we can be as follow-up of NEP. So in the research of in academia also, ISRO is engaged with various centers and premier institutions like IITs and IIScs and NITs, like space technology cells. This is spread all over India. We are very, very particular that the spread should cover the entire India. So as you can see in the map, the space technology cells at IITs and IIScs, the space technology innovation centers at NITs, regional academic centers, at NITs, etc., and many innovation centers supported by us. And of course, the new Indian space policy in tune with the requirement of the Outer Space Treaty signed in 1967, we have already done now in 2023, which really encourages advanced research and development in space sector, linking the industry and academia. So a new center called Indian National Space Promotion Authorization Center is also formed with an aim of I would say, promote, handhold, and regulate the industry, non-governmental sector of India to carry out their space-related activities. This includes startups as well as academia. So it is a single window agency for permitting and monitoring private sector space activities, permitting usage of ISRO facilities. So that this is one major deterrent, I would say, as far as academia or any startup is concerned, because it involves huge investment. So ISRO is ready, and already ISRO is sharing its facilities which are not otherwise available in India elsewhere. So these are all some of the initiatives that ISRO has done in the recent time, and InSpace is the nodal center. If you want to bring a satellite, if you want to build a satellite, you can contact InSpace. So as far as ISRO and industry interface, this is the last slide, I suppose. Yeah, I'll quickly conclude. ISRO industry interface philosophy, as you say, is more towards Atmanirbhar, starting from 80s, where we were basically importing raw materials. Finally, now we have reached a stage where absolutely indigenous raw materials are being used, especially in the mechanical and material area. But I'm sure you all know that we are not that strongly placed as far as electronics industry is concerned. We are still dependent on a huge import of electronics industry, and I'm sad in one way that major Indian industries are not coming forward to really fabricate the world standard, space standard electronic items. Even a resistor or a capacitor or an inductor of good quality is not being made in India, and this is something now the government has really revamped the policy, and lot of support and encouragement is given, especially now, as you can see, the kind of support that is given for the establishment of foundries and establishment of paraphernalia for foundries for making VLSI chips, which is going on, which is absolutely essential if we want to be self-contained, Atmanirbhar with respect to electronics industry. And so coming to technology transfer, ISRO has already a cell which is primarily instituted to see that technology is transferred to industry so that they can manufacture the products using this technology, not only for space requirements, but also for requirements which are for the commercial as well as for the people. Like, for example, the greatest example is the lithium battery. So this is a kind of spread that is happening in the technology transfer. So in short, let me conclude saying that the linkage of industry and institutions like ISRO, DRDO, etc., and academia with respect to the formation of the curriculum itself, to impart the knowledge to the students, is absolutely essential. It is also essential that the teachers are also getting equipped themselves to teach these aspects in an integrated and an innovative way, so that the students are better prepared to meet the challenges when they are put into the hot stove, or I would say when they enter into their professional domain. Thank you very much for this opportunity once again. May God bless all of you.